Okay, so we're going to continue on with the lathe setup procedures, and I changed what you can see on the camera. So let's go to number 9, mount the correct tool holder. Again, we're using the angled holder, and this is a cam lock. So this set screw I can move up and down and it sits on this little pin. And if I put this in the dovetail and turn this handle back, then I can't remove the tool holder. If I move this handle forward, the cam loosens and I can move this in and out. Okay. With the set screw, I can use this 1/8 Allen and bring this up and down, and you'll see how that centers the tool on the workpiece. So that's number 9, clamping the tool holder to the tool post. 10, I'm going to clamp the tool bit, and I'm going to have these ground for you. I'm going to have a separate video that shows kind of how the rake of the tool, which is the cutting surface, and how to mount this correctly. I'm going to use the 532, loosen these set screws. I'm going to use a rag and make sure this is clean, the surface that the tool bit is going to sit on. And I'm not going to have this sticking out too far forward, so more than 1 inch is hanging off, and I'm not going to have this too far back to where I can't see the tip of my tool with my eyes. So just under 1 inch. I'm going to clamp the middle one finger tight, and then the other two. And actually, I just used the 2 outside set screws, this front set screw and the bottom set screw, so I know that I have clamping force just on 2 pivot points. Okay, so that's number 10. Number 11 is centering the tool bit vertically to the center of the workpiece. I do have my round stock already clamped here on my 3-jaw chuck. I'm going to bring my carriage forward. I'm going to bring my slide forward, and sometimes at the same time. And I'm going to use my 6-inch scale. And as I bring the tip of the tool to the workpiece, I'm going to slowly clamp, just very gently, my scale with the tip of my tool here. And I want to make sure I'm going to look in this direction. I'm going to bend down and look with my eyesight in this direction. And I'm going to make sure that my 6-inch scale is straight up and down. If my scale is leaning a little bit towards this direction, I know that the tip of my tool is pushing the scale over the top of the part. So what I would do is I would back this up. I would turn this set screw counterclockwise to lower the tip of my tool, and then I would go in and try again and put this very slowly and gently, not digging into the scale or to the workpiece, and check it again. If it's too low, I would back this up, take this off, and I would go clockwise, bringing the tip of my cutting tool up towards the center line of this, my spindle of my workpiece. Okay, so I check this looks good. That is number 11. We're going to do this every time we put in a new tool. The round stock should be centered on a 3-jaw chuck. A universal chuck will be centered each time we put it in. But once this is adjusted for this particular tool, this tool will always be on center on this machine. Okay, so number 12, I'm going to set the correct spindle RPM. Some of the machines are variable spindle, some are not. So I'm going to move the camera around again to the front here and show you the front of the machine. So on this particular machine, we've got, really there's 2 levers here. On the top, that shows the spindle RPM. There's a chart here. I'm going to measure, this is a piece of aluminum. So I'm going to measure the diameter of the workpiece. On the mill, we would measure the diameter of the cutting tool, and we'd use the same formula. On this is, I measured this at 700 thousandths. So I'm going to multiply 4 times the cutting speed for aluminum is 300. So that's 1200 divided by 0.7. So that would be, it'd be 420, it'd be 3200, it'd be about 2400, around 2200 RPM. I'm going to go quite a bit slower than that. In this case, the max on this is not a very variable speed. These are levers here, not dials. So the next speed down, the highest speed is 2500, then I have 1700, then 1200, then 800. So I could probably cut this at 1700, but I'm going to actually go to 1200. I'm going to push this in and rotate as I do it, and that looks locked into place. On the lever style, if these are a little finicky, you can always open this and rotate the spindle by hand as you're rotating the levers. Okay? So that's number 11. Number 13 is I'm going to set the correct feed rate. Now, on the lathe, we're always going to use auto feed. Well, not always, but most of the time, we're going to be using auto feed. And the auto feed rate is basically just a chip load. And there's going to be a couple formulas that we're really going to be working with, where we're going to be able to calculate the chip load on the lathe and the mills. It's actually the same thing. The difference being on the lathe, this is a single point tool. On the mill, oftentimes you'll have a 2-flute or a 4-flute tool, like a 4-flute end mill or a 2-flute end mill. So you would multiply the chip load by 4. But in this case, we have just one cutting tip. So we're going to go with the higher end of the finish chip load. So we want, when we do a finish cut, we're going to take between 3,000 and 6,000ths material off per revolution. If we were roughing and we needed to save time, we would take anywhere from 7,000ths to 20,000ths per revolution. There'd be a lot more cutting pressure, it'd be tougher on the tool, but it would save us time, and that would be considered a roughing operation. For what we do in this class, even though we will be roughing off some material, we're not going to take off that much material, so we can just keep using that same feed rate. And on this particular machine, I can look on my feed chart, and I'm looking at, and most of these have 4 different charts. The upper right is a inch thread, upper left. Upper right is metric thread, lower left is inch feed, and then lower left is inch feed, lower right is metric feed. So we know we're going to be using the inch feed here. I'm going to look at the chart, and this actually has 2 gearings, F and G. This particular machine is always in F. So I'm going to go to where it says 5,000ths here on the chart, and I'm going to make sure where it says 5,000ths, all of my dials are going to read AR1X. So this pin shows is this lever has a little notch here that shows that it's in ARX. And then down here, the dial for the numbers is set to 1. So I know that when I turn this on and I turn the auto feed on, every time the spindle rotates 1 revolution, my auto feed is going to move 5,000ths of an inch. So that's a good finish feed. It's a finish feed that we can also use for roughing. Okay, so on all the lathes, some of the lathes do have variable RPM, but all the lathes do not have variable feed. The CNC lathes do, and it's a setting called G96, where the chip load stays current as you go closer to the center of the part. And that's why when you hear on a CNC lathe they're facing, you'll hear the RPMs, the revolutions speed up. We don't have variable speed here, and because of that, we don't have variable feed. So all the feeds on all the conventional lathes are set by levers, not by dials. Some of the lathes in here do have variable speed, but it doesn't change through the cut, and they're set by dials. But again, we do not have variable feed on these lathes. So on this, that is setting the correct feed rate. That's number 13. Number 14, I'm going to move the carriage to the left and check for clearance by rotating the chuck. So I'll open this up and you can see. I know my tool is going to finish right here very close. So I'm going to want to always make sure that I rotate this around. And I have clearance here, both on the bottom of my tool holder here and this side of the tool, that my tool holder is not hitting the chuck. That's why it's nice to have the angled holder. That's also why we have this set at 29 degrees with the tool holder set to the very far left of the compound rest. You can see I have plenty of clearance over here. Okay, so that's number 14. So that's pretty good. That looks good to go. At this point, this is what I'm expecting everyone to get on their first operation, to get to this point. And then I'll watch everyone do their first cut on their first assignment. And then after that, you would have been checked out on the lathe, and you can continue with your projects off the drawings and the video demos without having me to look at your setup again once you've been checked out. But I do want to add also that if you don't necessarily need to always rely on the video as well. I mean, if you're not sure, it's nice to go back and look at the video again, maybe over the next beginning weeks of the semester. But if you're in the shop and you have a question, ask me a question, and I'll definitely come and answer your question. I mean, this is why we're here, even though we're in a kind of an unusual time. I still am available in the lab to answer all those questions to get you proficient on the machine.